Before starting shielded metal arc welding operations, prepare all necessary apparatus and tools and confirm that they function properly. For the arc welding machine, check and confirm that the primary side cable and the secondary side cap tie table are securely connected and completely covered with insulation tape, that their rubber coating is free from cracks and other abnormalities, and that the welding machine is grounded properly. Confirm that cables have diameters appropriate for the capacity of the welding machine to be used. The electrode holder should be light in weight, easy to hold, and be coated completely with insulation. The electrode should also be easy to attach and detach. The earth clamp is the contact point connecting the secondary side cable with the base metal and workbench. A slack earth clamp will lead to arc instability and can cause heat generation. This DVD uses a practice plate as the base metal. When using an AC arc welding machine, confirm that the automatic voltage reduction device works properly. Arrange your tools in order and within easy reach. Wear cotton work clothing and a work cap. Footwear should be rubber-soled shoes made of leather. Gloves, apron, arm covers, and foot covers should be made of leather, be free of cracks and stains, and be fitted properly. Use a face shield free of breaks, and properly fit it with a filter plate corresponding to the welding current to be used. Regarding covered electrodes for shielded metal arc welding, prepare an ilmenite type. Hereafter we will refer to covered electrodes as welding rods. Please ensure that the welding rods have been dried properly. How you set the welding current will have a significant impact on welding performance. Not only must you know the value of the welding current suitable for your task, but you must also be able to set the required current value quickly and accurately. Procedures for setting welding current are as follows. Allow the welding rod holder to hold the welding rod stud at a right angle. Switch on the arc welding machine's secondary side power source and confirm that the automatic voltage reduction device works properly. Turn the current adjusting handle to set the indicating needle to the desired current value. Hold the welding rod holder with one hand and use the other to let the jaw of the portable ammeter hold part of the cable close to the holder. Strike the tip of the welding rod vertically against the practice plate, then pass a short circuit current. Now check the portable ammeter reading to see if the short circuit current is about 10 amps higher than the desired current value. If not, turn the welding machine's current adjusting handle so that the ammeter needle indicates this value. After adjustment, examine the current when a stable arc is being generated. Strike the welding rod against the practice plate and generate an arc. Maintain the arc so that it makes a cracking sound. Read the portable ammeter indicator needle at this time. The needle moves right and left, so take your reading from the center of the amplitude. Check if the value read at this time is almost equivalent to the short circuit current minus 10 amps. In case of a deviation, make fine adjustments using the adjusting handle. Here we'll show you the basic posture for the flat welding position. Sit forward in a chair placed in front of the workbench with your knees apart. Lean your upper body forward. Raise the arm holding the welding rod until it's nearly horizontal. Now relax your shoulders, relieving them of tension. Striking an arc and maintaining arc length are done like this. Place a practice plate and a welding rod on the workbench. We recommend a mild steel plate around 16 millimeters thick and of medium size. Prepare an ilmenite type shielded metal arc welding rod suitable for use with mild steel. Core wire diameter should be 4 millimeters. Set the current at approximately 180 amps. We'll begin by showing you how to generate arc using the tapping technique. In this technique, an arc is generated by lightly striking the tip of the welding rod near the welding start point on the practice plate, and then pulling the rod tip several millimeters away from the plate the moment short-circuiting occurs. You can also generate arc using the brushing technique. In this technique, you generate an arc by rubbing the tip of the welding rod against the practice plate as if you were striking a match. Relative to the tapping technique, it's easier to generate an arc with the brushing technique. However, the plate is vulnerable to staining, and the welder often misses the targeted welding start point. We recommend that you accustom yourself to the more reliable tapping technique. Once you're capable of generating an arc with ease, your next task is to practice maintaining the arc at the proper length and transferring it sideways. When an arc is generated, the core wire of the welding rod melts and the coating flux decomposes and gasifies, steadily reducing the length of the rod. Therefore, if the holder continues to be held at a constant height, the arc will become longer and eventually vanish. It's necessary to learn how to supply the welding rod while maintaining a constant arc length. You do this by lowering your hand at the same speed with which the welding rod is being consumed. Generally speaking, the arc should be about the same length as the width of the core wire's diameter. In our example, the core wire is 4 millimeters in diameter, so the appropriate arc length is 4 millimeters. However, you should be aware that the protective tube blocks some of the arc from view. This being the case, if the visible part of the arc length is about 2 millimeters, consider it appropriate. A bright cracking sound can be heard when the arc is maintained at the appropriate length. However, the sound becomes duller as the arc gets longer. Learn to listen to the arc and adjust your arm accordingly. Once you've mastered the skill of maintaining a constant arc length, your next challenge is to learn to transfer the welding rod at a uniform speed and in a straight line without changing the arc length. Begin by tilting the welding rod 70 to 80 degrees towards the direction of movement. A raised belt of black material, known as slag, forms on the track of the welding rod, protecting the deposited metal. Deposited metal is a solidified mass of molten core wire mixed with molten base metal. The slag is broken by the slag hammer and removed, revealing a metallic section whose glossy silver surface has a wave-like striped pattern. This is known as a bead. Shifting a welding rod in a straight line creates what's known as a stringer bead. Here's a tip you should heed when depositing a stringer bead. The speed of welding rod transfer, the arc length, and the welding rod's tilt angle should be adequate and uniform. Recommended width of the stringer bead is 2.5 times the core wire diameter of the welding rod used. This means that the stringer bead width should be about 10 mm for a rod with a core wire diameter of 4 mm. When welding is started, a liquid substance known as a pool appears under the arc being generated. Watch the pool carefully as it grows. Once the diameter of the pool is almost equal to the width of your desired bead, begin to shift the welding rod sideways. Once you can perform this operation naturally and without difficulty, you will be able to create and deposit a neat stringer bead. In other words, careful observation of the pool is the first and most vital step towards welding proficiency. The bead is most vulnerable to defects immediately after you begin to generate the arc, because the arc is still unstable and there is not yet enough shield gas. Also at this point, the base metal is still cold, a condition that often leads to weld defects such as incomplete joint penetration and incomplete fusion. Meanwhile, a cavity known as a crater is created if the arc is suddenly discontinued at the end point of the weld seam. Insufficient bead thickness and sudden cooling mean that craters are highly prone to cracking. Therefore, you must use the retract start technique at the bead start point to stabilize the arc. At the end of the bead, discontinue arcing after filling any craters by moving the welding rod as if you were drawing a circle. When a welding rod runs out halfway through the weld, you must stop welding and resume welding after replacing it with a new rod. The procedure for joining beads is as follows. Shorten the arc length and immediately discontinue welding. Remove slag around the crater and clean the area. Start an arc from a point slightly ahead of the crater. Return the rod while providing preheat using a slightly longer arc. Continue practicing until the seam joint does not stand out. When you're performing V-groove butt welding of a medium or thick plate, it's difficult for a stringer bead to cover the weld seam width of the upper layer. In this case, we solve the problem by using what's known as weaving bead operation, a method whereby the welding rod weaves between both sides of the weld seam. The resulting bead of greater width is known as a weaving bead. Here are some tips you should follow when weaving. Maintain the rod at a uniform pitch, interval, not too large, not too small. Too large a pitch could result in defective welding on parts over which the rod failed to pass. Too small a pitch could cause the plate to overheat, resulting in a rough-shaped bead. Manipulate the rod a little faster for the section between the weld toes, but move it slightly more slowly or stop it briefly at the weld toes. Maintain a constant weave width, up to about 3 times the core wire's diameter. Here we'll also show you an example of weaving bead joining. Crater treatment is conducted at the bead end. Here is a completed weaving bead. Welding the fillet of a joint consisting of 2 base metals coming into contact with each other in a T-shape is known as fillet welding. Fillet welding is a frequently used joint type, so you should accustom yourself to it. Prepare 2 steel plates for practice and a 4mm diameter welding rod of the ilmenite type, and set the welding current at approximately 180 amps. Begin the arc about 20mm inside of the weld seam start point and return it to the start point while making the arc somewhat longer. As soon as the arc returns to the start point, deposit a stringer bead by letting the rod tip lightly touch the corner of the base metals. Do not change the rod holding angle during this process. However, when slag on the pool appears to move ahead of the rod, tilt the rod towards the direction of movement and use the force of the arc to push the slag backwards. Most importantly, make sure you're carefully observing the pool. Once the bead has been deposited, remove the slag and examine the bead's appearance. Undercuts found at the weld toe on the vertical plate side can be attributed to causes such as too high a welding current, an error in the rod holding angle, excessively fast rod manipulation, and lack of arc length uniformity. Now check the horizontal plate. Overlapping is a defect frequently encountered on the horizontal plate side during horizontal fillet welding. Overlapping means that the deposited metal has not fused with the base metal, but merely lies on top of it. Causes include excessively low welding current and slow rod manipulation. When inspecting fillet position welding, the most important point is whether or not the fillet weld legs are uniform. In most cases, the cause of irregular fillet weld legs is a welding rod held at an improper angle. The rod holding angles suggested previously serve as a yardstick for proper welding. As you accumulate practice with fillet weld legs, you're encouraged to find the rod holding angles that work best for you. When you want to deposit a bead of greater weld leg in horizontal fillet welding, you can use either the multi-pass welding technique or the weave welding technique. Conduct more than one pass if the required fillet weld leg is relatively large, because weaving will not suffice. Regardless of the technique used, fillet weld leg should be uniform in length, and good care should be taken to avoid undercuts, overlaps, and mixing of slag with deposited metal. While flat position welding is the basis for most welding operations, sometimes the welder has to work in other, more unnatural positions. As an example, practice vertical position welding here. Compared with the flat position, the motion required for vertical position welding makes your arms tire more rapidly. It's essential then you adopt a posture that minimizes the burden on your arms. Fix the practice plate so that its end point is lower than your horizontal line of sight. Doing so will allow you to observe the pull for the duration of the welding process. Place your body either in front of the weld seam or slightly to the left if you are right-handed. If you are to work while seated, open your knees wide and take care to keep your right hand from coming into contact with your knee. In either case, keep your elbow away from your side so that the motion of your arm is not impeded. Two techniques are used for vertical welding: the common upward welding and downhill welding. Following are some tips for upward welding. Prepare steel plates of a moderate size and fix them to the jig so that their upper end is lower than your horizontal line of sight. Select a welding rod with a diameter of 4 mm and attach it to the rod holder at an angle of 120 degrees. Set the electric current to 120 amps and find an optimum value as you accumulate practice. After generating an arc at the lower end of the practice plate, use a relatively longer arc and wait until the arc is stabilized before proceeding. Once the arc has stabilized sufficiently, shorten its length to about 3 mm and move the rod straight upward. Hold the welding rod at an angle of 45 degrees to both base metals. The key point here is to strike, as if you were spraying, an arc into the inner part of the fillet and fuse the two base metals uniformly. While rod manipulation can be linear in principle, allowing the rod tip to weave slightly makes it easier to get the desired timing for upward manipulation. Beware of making the arc too long, because this will cause undercuts. Next, you'll practice depositing a weaving bead. Set the current at 150 amps and adjust as necessary as you proceed with the welding practice. As with flat position welding, manipulate the rod a bit faster in the center area and slow down at the weld toes. Note, however, that droops are likely to occur unless the manipulation speed in the central area is faster than that used for flat position weaving. Also bear in mind that manipulating the rod very slowly at the weld toe areas, as you would for flat position welding, may result in a scale-like bead. This should be avoided. Try to maintain an optimum pitch of upward motion, not too large, not too small. Given the upward motion, too small a pitch could result in droops or overlaps, which should be avoided. When manipulating the rod, make sure that it's always constantly moving upwards. Avoid repetitive movements over the same area. Shown here is the equipment required for TIG welding. TIG welding power source. This is a common type of manual TIG welding torch. Argon gas, the shielding gas, is contained in cylinders under extremely high pressure. For this reason, it cannot be supplied directly to the welding torch. A pressure regulator is used to lower the pressure to that suitable for welding. The regulator also maintains a certain amount of pressure even when the cylinder's internal pressure drops as the gas is depleted. The gas flow controller is designed to optimize the flow of gas coming from the torch nozzle. The remote controller is designed to allow handy control of welding conditions, such as welding current, pulsed current, and crater current. The TIG welding machine has functions peculiar to TIG welding, so you must set each function properly. The gas pre-flow function prevents oxidization of the tungsten electrode and base metals by letting the shielding gas flow from the torch nozzle before the arc starts. Pre-flow time is the length of time that elapses after the switch of the torch is pushed, the shielding gas begins to flow, and the arc is generated. This can be adjusted in units of 0.1 of a second using a timer provided on the welding power source. Pre-flow time is usually set in the range of 0.3 to 0.5 of a second. It's customary with TIG welding to begin the arc without bringing the tungsten electrode into contact with the base metal. A high-frequency generator circuit is used to create the arc. High-tension, high-frequency voltage is applied beforehand between the electrode and the base metal, inducing arc generation. Not only do craters mar the bead's appearance, but they may also lead to cracking and other defects, so craters should be filled properly. This operation is known as crater treatment or crater filler. Many TIG welding machines are fitted with a function to facilitate crater treatment by downslope current control, that is, lowering the welding current to a preset crater current at the weld end. It's advisable to use this function for crater treatment. Set the crater filler current about 30% lower than the welding current. Contrary to pre-flow, gas post-flow protects the still-hot electrode and base metals from atmosphere-induced oxidation by allowing the gas to continue flowing for a certain period of time after the arc has been discontinued. The duration of post-flow can be set across a wide range, from a minimum 5 seconds up to a maximum 30 seconds, according to the welding current and electrode diameter being used. Here we'll show you how to prepare for TIG welding. For this exercise, we'll use stainless steel plates of a moderate size, 3 mm or so in thickness. Cleanse the groove faces and their vicinity using organic solvent like acetone. Prepare tungsten electrodes. It's important to polish the tip of the electrode into the proper shape. Here's a yardstick for electrode extensions relative to the joint shape. If electrode extension is too large, gas shielding will not function properly. If electrode extension is too small, the weld pool will be hidden behind the nozzle, resulting in poor operability. In principle, filler rods should be of the same material as the type of base metals to be used. Prepare a dust respirator, a helmet with shield plate, and leather gloves for welding, and fit them properly. Rubber-soled leather shoes are recommended. Since specific power source operational procedures vary according to the welding machinery being used, please follow the instructions provided in the operating manual attached to your particular welding machine. Here are operational procedures for welding with crater treatment. Set the crater filler switch on the power source to with. In this state, an arc will be generated when the torch switch is engaged, but arcing is not extinguished even when the switch is released. As you approach the end of the weld, press the switch again and the crater filler current is engaged. Crater filling is carried out by a process known as downslope, when the welding current is switched to the lower crater filler current. After crater treatment is completed, release the switch and discontinue arcing. Do not move the torch until gas post-flow is over. Practice this technique without an electrode until you've become accustomed to handling the torch. Use a wire brush to polish the area of the base metals on which you will deposit the bead, then degrease the polished part with solvent. Generate an arc and move the torch in a straight line sideways while maintaining an arc length of about 4 mm. There are 2 points to remember here. Do not change the arc length or torch holding angle midway through the process. And make fine adjustments to the torch moving speed to maintain a uniform pool width. Release the torch switch at the end of the bead to extinguish the arc, and remove the torch from the base metal only after the gas post-flow has come to a halt. Here we'll show you how to deposit a stringer bead using a filler rod. Begin by practicing hand feeding of the filler rod. Hold the filler rod lightly and use your thumb to feed its tip into the pool. Generate an arc and form a pool at the start end of the bead. Once the pool size has grown sufficiently, hold the torch and the filler rod at the angle shown here. Immerse the tip of the filler rod in the edge of the pool. Begin melting the fused tip of the filler rod as if you're letting the pool absorb the fused filler rod. Here are a few points to remember. Do not insert the filler rod tip directly under the arc, but let the filler rod tip touch the end of the pool farthest from the arc. Do not let the filler rod touch the electrode. And keep the filler rod tip within the stream of shielding gas. Once a proper amount of filler rod has been fed, immediately pull the rod out of the pool. Continue welding by repeating this process with a constant rhythm. Pay attention to the pool width at all times, and try to keep it uniform by adjusting both the torch's advance and its pause, as well as the amount of filler rod being fused. Remember to extinguish the arc only after craters at the end of the plate have been filled. Once you've become accustomed to handling the filler rod, apply this technique to deposit a weaving bead. The purpose of weaving is to create a bead wider than that of a stringer bead. As a rule, however, the weaving amplitude should be kept within the pool's range and should be no larger than 5 mm to ensure a sufficient gas shield. First, make a pool at the edge of the plate in the same manner as you would for a stringer bead. Once the pool has spread sufficiently, shift the torch to the other side across the center line of the weld seam, then feed a proper amount of filler rod. After briefly suspending the torch to fuse the filler rod into one end of the bead, shift the torch quickly to the end on the opposite side and feed a proper amount of filler rod. Repeat this process with dexterity. The key point of this practice is to maintain a uniform weaving amplitude and pitch. Craters are the cause of defective welds, so fill them carefully. Since many TIG welding power source units come with a crater filler function, use it. Unless a weld seam is extremely long, it's advisable to avoid bead joining because this deteriorates bead appearance and weld quality. If discontinuing beading for resumption later is unavoidable, please follow this procedure. Begin arcing 15 to 20 mm from this side of the point of discontinuance and proceed with welding while fusing the previously deposited bead well and adding an amount of filler rod sufficient to add necessary bead height and width. Here we'll show you how to perform horizontal fillet welding. Degrease the practice plates and filler rod in advance using solvent. The electrode extension should be a little longer, about 6 mm. Once the pool has been fully formed, commence welding, holding the torch at the angle shown here. In horizontal fillet welding, it's essential that the arc length is as short as possible. This allows you to melt the base metal sufficiently and avoid incomplete joint penetration into the root. Never give priority to melting the filler metal. With horizontal fillet welding, heat will concentrate on the vertical plate side, which tends to melt first. To accommodate this characteristic, slightly shift the aim of the arc to this side of the horizontal plate rather than focusing it on the corner. Try to heat the horizontal and vertical plates at a ratio of 6:4 so that a pool forms on both plates simultaneously. As is the case with fillet welding, polish the area along the weld seam using a wire brush. Use solvent like acetone to degrease the plates fully and wipe the filler rod surface well using solvent. Set the extension from the tip of the tungsten electrode nozzle at about 5 mm, a little shorter than that for horizontal fillet welding. Once the pool diameter has grown to about 8 mm, start feeding the filler rod. Try to maintain a uniform bead width by making fine adjustments to torch feeding and the timing and amount of filler rod feeding. The point here is to make sure that the added filler rod fuses well with the pool. Immerse the filler rod in the edge of the weld pool and feed the filler rod, allowing the pool to absorb it. Pull out the filler rod. Advance the torch. Feed the filler rod. Perform this series of actions with rhythm, steadily, and without stopping. The plate temperature rises as you approach the end of the bead, and you run the risk of burn-through and bead width expansion. Accommodate this risk by gradually increasing both torch speed and the pace of filler rod feeding. Having come to the bead end, release the switch to discontinue arcing once the height of the crater fill is about the same as that of the bead. Keep the torch in the same position until gas post-flow is over. Here we'll explain preparations for gas welding. Turn the oxygen cylinder valve pressure regulator port sideways and to your left. Raise the valve to blow off any foreign matter adhering to the pressure regulator port. Attach a thread for connecting the pressure regulator. After confirming that packing is in place inside the pressure regulator's cylinder valve port, slowly screw the nut onto the pressure regulator connecting thread as shown here. First tighten the nut by hand, then fix it securely using a wrench. Fix a rubber hose to the oxygen pressure regulator, then tighten it securely. Confirm that the pressure regulating handle is sufficiently loose. Rotate the cock handle to open the cylinder valve less than a half turn. Use the primary side pressure gauge to check the residual oxygen pressure. Adjust to working pressure by slowly rotating the pressure regulating handle clockwise while monitoring the secondary side pressure gauge. Now we'll explain preparations for acetylene gas. Confirm that packing is attached to the cylinder valve gas output port. Place the pressure regulator clamp on the cylinder valve, align the cylinder valve connection port with the gas output port, then fasten the clamp handle securely. Fix the red rubber hose to the acetylene pressure regulator securely. Confirm that the pressure regulating handle is sufficiently loose. Open the acetylene gas cylinder valve to conduct acetylene gas pressure regulation. Set the acetylene gas working pressure to about 10% that of oxygen. Open the acetylene pressure regulator vent valve and feed acetylene to the torch. Use soapy water or specially designed liquid to test for gas leaks. In particular, carefully check the joint between the pressure regulator and the gas cylinder and hose connections. Connect the oxygen hose to the torch. Feed oxygen to the torch. Confirm the feeling of suction in the following order. Open the oxygen valve. Put your fingertip on the acetylene hose port and confirm a feeling of suction. Inability to confirm suction indicates the possibility of torch malfunction or other trouble, a dangerous situation. Connect the acetylene hose to the torch. Feed acetylene to the torch. Now you're ready to ignite the torch. Slightly open the acetylene gas valve and ignite the gas. As oxygen is fed, you can create a standard flame. A red carburizing flame is created first, which gradually turns pale blue as oxygen streams out. Feeding the excessive oxygen makes an oxidizing flame. Stop the preheating valve once you've established a standard flame that has a proper balance between oxygen and acetylene. Here, let's look at the flat position in which you perform welding while sitting in a chair. As is the case with shielded metal arc welding, it's important to maintain a posture that allows you to transfer the torch along the entire length of the weld seam without difficulty and to observe the pool. Use a torch tip suitable for the plate thickness and fix it securely. Now we'll show you operations for flat position butt welding of thin sheets. Prepare 2 pieces of 2 mm thick steel sheets. Keep a distance of 2 mm or less between the 2 plates and provide tack welding at both ends and at the center as shown here. Weld from right to left, a method known as push technique. Remember that the main purpose of full welding is to securely fuse the plate's roots. Welding rod feeding serves a secondary purpose of filling the gaps between the roots to facilitate beading. Heat the 2 plates uniformly and proceed with welding at a uniform speed while paying attention to the size of the small hole made at the tip of the pool. At the end of the weld seam, feed a sufficient amount of welding rod to fill in any craters. A gas cutting torch is linked together by 2 tubes, the mixed gas tube and cutting oxygen tube. Pre-mixed fuel gas is supplied to the mixed gas tube, while only oxygen is supplied to the cutting oxygen tube. These 2 tubes differentiate the cutting torch from the welding torch. Ensure that the torch tip is securely and properly attached to the cutting torch. Improper attachment can result in backfire. Here's how to handle the cutting torch. Open the fuel gas valve slightly, then use a lighter to ignite the acetylene gas. After ignition, open the preheating oxygen valve to feed oxygen. As oxygen is fed, the red flame gradually turns pale blue. Once the flame has become a standard flame, stop the preheating oxygen valve. If the cutting oxygen valve is opened, the standard flame is degraded. so open the preheating oxygen valve to re-establish the standard flame. Close the cutting oxygen valve once a standard flame has been established. Creating a proper preheating flame ensures that a standard flame is formed while the cutting oxygen gas stream is being fed. Let's look at this series of operations again. To ensure good quality cutting, it's important to maintain a relaxed posture so that the cutting torch can be transferred without difficulty from the time you begin cutting to the time you finish. Begin preheating. Keep the torch immobile to conduct preheating until the plate edge becomes red hot. At this time, do not preheat excessively until the plate edge begins to melt. Begin cutting. When dealing with a medium or thick plate, hold the cutting torch tip at a right angle to the material's surface. Also pay attention to the condition and direction of sparks emanating from the plate's bottom surface. A sudden decrease in the volume of sparks, or sparks scattering in the direction opposite the cutting direction, indicate that the cutting speed is too fast. Keep your left hand ready at all times so that you can quickly close the valve if necessary. To guarantee high-quality cutting, proper preheating must be conducted using a preheating flame that has a length and strength suitable for the thickness of the plate to be cut. If your flame is too strong, upper corners of the plate's cut surface melt and become round. Too weak a preheating flame may cause the cutting operation to stop halfway through. In the event cutting stops halfway through, close the cutting oxygen valve immediately and resume the operation from the preheating stage. For a thin sheet, incline the torch tip markedly in the direction opposite from the cutting direction. Guard against backfiring, which can occur if the torch tip becomes clogged as a result of coming into contact with the material's surface. After a period of continuous use, the torch can become overheated. Cool it down by soaking it in cold water while feeding out a small amount of oxygen. Omitting this process may result in backfiring. Now let's learn about flame brazing with a gas welding torch. This bonding method is convenient and used extensively because it offers superior joint strength and produces less distortion than with gas welding. Prepare 2 copper pipes. If the pipes are of the same diameter, process the tip of one pipe to make a flange. Ignite the torch and adjust the flame to make a standard flame. You will use a brass welding rod with a 2 mm diameter flux. Since brazing operations using a flux involve the risk of generating hazardous metallic vapor and gases, it's essential that the job site is well ventilated and that you wear a dust respirator. Preheat the whole area around the joint. Continue to heat until the whole of the joint turns reddish-orange. Remove the flame and allow the tip of the brazing filler metal with flux to touch the brazing start point. The preheating temperature is appropriate if the filler metal tip melts and spreads like water over the fusion face. Feed the filler metal into the groove while applying a flame to ensure the filler metal fits well with the groove. Once the cladding has been sufficiently built up, remove the flame and allow the cladding to cool. Spread the filler metal over the entire joint area. At this stage, cladding should not be built up too thickly. Elaborate post-treatment is important when brazing because residual flux around the joint may cause corrosion. Soak the joint area in warm water and use a brush to polish the cladding surface and remove flux tailings and slag from the joint area. Now we'll explain flame brazing with silver brazing filler metal, the main constituent of which is silver. Prepare a copper pipe and a brass nipple and connect them together. Prepare a 2 mm diameter silver brazing rod and flux. Prepare your flux by combining silver brazing flux with water and kneading the mixture. Ignite the torch and adjust the flame to make a standard flame. Heat the area around the joint. Feed the flux after heating for a while. The flux begins to melt into a transparent liquid. Feed the brazing filler metal to the joint. Spread the filler metal uniformly over the joint area, using the flame's force to apply a coat. Soak the joint area in warm water. Use a brush to polish it and remove flux tailings. This is an example of a plasma cutting power source unit. Properly assemble and inspect the cutting torch in accordance with your unit's operating manual. While engaging in cutting operations, be sure to use goggles, a long-sleeved cotton work shirt, apron, leather leg covers, and so on. Here are procedures for straight-line cutting. Draw a marking offline on the part of the plate to be cut. Generate a plasma arc as soon as you depress the torch switch to begin releasing air. Begin to move the torch along the marked-off line. The best cutting speed will find the plasma jet coming out below the plate's bottom surface and drifting slightly backward. If the torch inclines to one side of the cutting line, spatters will fly to the other side. Use this clue as a yardstick to determine if the torch is upright. At the cutting end point, turn off the torch switch to complete the cut and keep the torch immobile for the duration of afterflow. Inspect the cut surface. If it's markedly deformed, check the electrode and the tip for abnormalities. This DVD contains numerous examples of skills you should acquire. We hope you will improve your skills significantly by learning a lot from this DVD.